Okay, so we're ready. Thanks a lot for giving me the opportunity to speak here to the organizers of the HPC Advisory Council. And I'm happy to present Qlustar, our cluster operating system, full-fledged HPC storage cluster operating system. Here, let's give me a quick outline of the talk. So first I'm going to give a brief introduction to Qlustar. What is it? What are its main components? Then I'll give an in-depth look of the Qlustar OS image technology, a very central part of Qlustar. Then next part will be an introduction to QluMan, that's the management infrastructure of Qlustar. That's a completely new management interface written from scratch, with many interesting features. And finally, I'm going to give an outlook of what's going to come in the remainder of this year, new features of the upcoming release of Qlustar. So what is Qlustar? Well, it's actually first professional Ubuntu Debian-based HPC cluster operating system. It had its first public release end of last year. But it's actually not a completely new system because it evolved from a former product of QLib Networks, which was installed and sold together as a complete solution tied to a specific hardware company. I mean, now QLib Networks is completely an independent software company, so we're providing this software as a publicly available one. So Qlustar is actually a complete HPC Linux distribution. So it's not like many systems, let's say, that you install some standard Linux distribution, then put some management software on top of it. It has a complete software package repository. You just have a single source of software there. It's based, as I mentioned, on Ubuntu and Debian, and it adds on top of that more than 200 software packages that are HPC, management, and system related. It supports standard compute and storage and GPU hardware. And we have our own installer that actually enables you to get a system up and run Linpack on a demo virtual cluster in just 30 minutes. So it's perfect for anybody who just wants to try it on a simple PC or whatever. The requirements are very low, actually, to just have a look at the system. It provides unlimited scalability. That's one of the main design goals of Qlustar as a whole and also of its management architecture. It provides, of course, pre-configured standard components that you expect in an HPC cluster, like up-to-date offset stack, like Lustre parallel file system support, pre-configured, various MPI versions, compilers, monitoring systems, high availability. It's all there, pre-configured and proven technology. And there is professional support provided by QLib Networks with different support levels as well. And as I mentioned before, it evolved from a product formerly known as QLib Beerbox, which was, as I mentioned, tied to a specific hardware vendor. And it actually incorporates more than 12 years of experience, I mean real 12 years, not man 12 years, in cluster design and operation, and installed on more than 100 clusters. So let's talk about some design principles behind Qlustar. I mean, one question you might ask is, what parts and packages are actually taken from the base distribution, which is Ubuntu and Debian? So the question that we ask ourselves is pretty simple, really. Is the base distribution package compatible with the Qlustar design, what we expect from an HPC system? Is it recent enough? Is it good enough from its features and so on? If the answer is yes, then we keep it, of course. Why do the work twice? If not, we replace it. And that really tells us, okay, we need to replace, let's say, the offset stack because it's not complete enough, it's not recent enough in the base distribution, and so on. So that's the design goal on that part, what goes in from the package side. Another very important point that is important for scalability, manageability, and so on and so forth, is to keep the system really lightweight and minimal. That means you really want to cut any overhead in your system, be it additional running services that you don't want, kernel drivers loaded, just additionally installed software packages. That's all been taken out. You just have the real HPC related stuff on your base system and on your compute node operating system. So you just put in as much as you need for the required tasks. The third very important principle is consistency and reproducibility. So how do we achieve that? What does that mean in practice? One point is that we package everything as Debian packages. So that gives you an intrinsic manageability, updatability, etc., reproducibility. We use a JIT version control system wherever it makes sense for our internal package development, etc., but also on the cluster for some configuration files. So you can always reproduce previous states. And we have a consistent layout for directory and file structure in the system, and also a consistent scheme for configuration options and configuration files. So that gives you a manageable system that's pretty easy to maintain and update and keep in shape. So, I mean, when you talk about cluster systems and cluster software, you hear the terms cluster OS, cluster operating system, provisioning systems, and so on very often. But as often as you hear them, as often it's not actually clear what is really meant. So I decided to just look at a couple of criteria that, in our opinion, a cluster operating system should meet, and then see how Qlustar does with that, and how other provisioning systems or software that uses standard provisioning does. I mean, one very important point is that there should be a single software package source if you want to call your system a cluster operating system. So is that true for Qlustar? Yes, it is. Because we have our own software package repository. Of course, many packages are taken from the base distribution, just like Ubuntu takes a lot of packages just from Ubuntu, repackages them. That's what we do as well for the ones that are good enough, as I mentioned previously. But we mix them in a consistent fashion, so we have our own software repository from where you get all these packages from. Is that true for other standard systems that use basic provisioning? It's not, because they typically use as a base system the standard Linux distribution, most of the time CentOS or Red Hat, sometimes SUSE, and then they put some stuff on top of that. Some packages, maybe just some additional like management software, and that's what they call their cluster software operating system stack. So another important criteria is whether the system software is all packaged. That's true as well for Qlustar. That's true mostly as well for most provisioning systems, but an important component of those systems actually is not packaged, and that's the operating system, the images that are transferred to the computer storage nodes and actually run on the compute nodes, because they are just typically created on the fly, created system images really, whereas in our case the images are composed of image modules which are completely packaged again, and so it's a completely reproducible, consistent software source for your images. So it's all completely packaged. So the next criteria is whether there is a reproducible and versioned installation once you've set up your system. Again, Qlustar is completely reproducible up to the images that you install, because it's all coming from versioned packages, etc., with change logs of up to the file level. And again, for provisioning systems, because of this property that they have, that they just create some images that administrators can modify and so on, that's not the case. So that means a cluster with a provisioning system set up at customer A will look, in most cases, pretty different to customer B. In our case, it looks exactly the same once it's chosen the same software components. So it's exactly reproducible. Next thing is there a single source for security updates? Again, Qlustar provides that, just like for normal packages, and there is actually a real security infrastructure that we provide regular updates and newsletters about security problems. And again, for provisioning system, that's not the case, because the security updates you get from their distribution that they're installing, and then if you're lucky, you get some security updates for the software that they put on top of that as well. And the final criteria is whether there is the system is consistently updatable. Again, Qlustar is consistently updatable because everything is packaged, so it's just for Debian insiders, apt-get update, apt-get install, apt-get dist upgrade, and your system is updated, including your operating system images. We have even an on-the-fly update mechanism for running nodes. Even though they run an image, you can transparently update from an updated image. You're running the image on the running node. And again, for provisioning system, that's not the case, because images are just created on the fly, so they are not consistently updatable. Of course, you can regenerate them, but the question is, do they contain exactly the same thing like before? Sorry. So you might ask, okay, that sounds nice and all that, but what is it for? What advantages does it bring to me? So there are a couple of clear advantages. And the first one is, of course, it's much easier to maintain and update a system that fulfills all these criteria. Any administrator will tell you about this. There are definitely much less sources of errors, because there is one integrated package stack rather than things coming from many different parts and sides. And the final one is that it's much simpler to support and debug such a system just because of its consistency, and that's an advantage both for administrators as well as for the software providers, because and both profit from that, because you have a much faster problem resolution by doing that. So here I just have a non-full list of software packages that are part of Qlustar. I'm not going to go through all of them. It's going to take too much time. I mean, just the main one I mentioned already: full office stack, Qlustar, different workload managers. Our preferred one is Slurm, but we also support Torque, Grid Engine, various OpenMPI versions compiled for various compilers. And MVAPIC 2 with GPU support, the most recent one, etc., etc. So I'm not going to go into detail. So let's come to the topic of the operating system image technology that the Qlustar provides and is a central part of it. So as I mentioned before, we're running the compute nodes from RAM disk images. So any compute node or storage node is not booting from a local disk, but it's running directly from RAM, the RAM disk image that it's received from the network. And this RAM disk image is very lightweight and minimal, one of the design principles I mentioned before. So RAM disks are typically 100 to 250 megabyte of size. That depends really on the chosen image modules that actually make up this image module. The core module, that's already enough to provide the basic functionality for a compute node, is just 100 megabyte in size. I mean, that's the whole operating system. That's all it needs, really. I mean, in many installations, you need 10 times of that just to have really a base functionality. And if you put in everything like NVIDIA support, Lustre support, OFET, you still not beyond 250 megabyte. So you compress all this, and that means you transfer like 30 to 50 megabyte over the network, and you have a booted system. So you can just imagine how fast you can set up hundreds or thousands of nodes just with this mechanism, because there is no network load and also no time involved really to get the system up and to do updates and changes. Because it's just reassigning different RAM disk images to nodes to do updates, I mean complete updates or reconfigurations. As I mentioned, there is no installation on disk ever. The system runs completely in RAM. There is no waste of RAM, because nowadays servers have like 64, 128, 265 gigabytes, so 100 to 250 megabytes for the operating system really nobody cares about anymore. It was different 10 years ago, but now it's not so. But still, of course, you can use the disks for scratch space, var file system. Actually, we usually advise doing that because it's easier to keep the logs and so on. You have swap space as well. But of course, the system runs in RAM, so running a diskless cluster really comes for free. I mean, that's a standard operating mode for this type of cluster. Or, of course, for storage nodes, you have disks for your object storage targets. Okay, let's have a look now how these images are really created. I mean, typically in provisioning systems, you have some kind of mechanism. You say, okay, I want this and this and this and this package, and then it just puts everything inside of the image, and that's it. In our case, our image modules are already pre-configured. They come as Debian packages, and they are actually created by our internal so-called third generation image generator. Third generation because it's the third time that we've actually rewritten it, improved it. I mean, really rewritten from scratch. The first version involved a lot of handwork, of course, but again, that was more than 10 years ago that we started with this. Then we had some semi-automatic generator, which still involved some kind of handwork. And now we have really a completely algorithmically based generator that makes sure that really only the stuff that is needed in the system really gets in there. So you define certain programs, it resolves the libraries that it needs and so on and so forth. The files that are accessed via a special caching mechanism, we actually do that. So we run a test run of the node. We have a caching layer between the real file system and between what gets written in the image. So just what goes through this caching layer and is actually used goes into the image. And that's per definition then a minimal image. I mean, you can't do less, because then if you put in less, then some of the functionality wouldn't work, some of the programs wouldn't work. But there is nothing more in it than that. So just as an example here, sorry, it's a little bit blurred here. Don't know whether you can read this. It's just a screenshot from a listing of the Debian packages, like a core module, Qlustar module, and so forth, just for this illustration. And how do you actually assemble these images now? I mean, you have these modules, image modules installed on your head node, on your boot server. And that's to assemble it and to actually make a bootable image out of it. That's where Qluman, the management framework, comes into the game. We have a graphical user interface for this, and so the first thing that you do actually to create or assemble, really, I shouldn't say create because it's just assemble the image, is you give it a name. Let's see. You give it a name. In this case, HA Qlustar. You choose a flavor, like in this case Ubuntu Precise. Sorry, I forgot to mention that we have a Debian and a Ubuntu variant of this whole operating system. Right now, the public version is Ubuntu only, based on 12.04, the long-term support one. That's actually the only ones we really support, only the LTS versions of Ubuntu, which come out every 2 years. And the first Debian version, the public one, will come out later this year. I'm going to come to that later on. So anyway, you choose the flavor here, so that's Ubuntu Precise, 12.04. You choose the version of Qlustar, that's in this case 8.0. Okay, this UniFS group I'm going to talk about later a little bit, that's a special feature still. And then you choose the modules here. So in this case, core module, that has to be in there all the time. Then the offset module, Qlustar module, and HA. So this would be what you need for an HA Qlustar head node, for instance, supporting InfiniBand. So that once that's defined here in the GUI, all you have to do is press this right button. Then your GUI is going to contact the head node. It's going to tell the head node to actually assemble this image. So we have these modules here that I showed you here as an example. They'll get assembled by the image assembler, and after, let's say, 30 seconds or so, it takes a little time to assemble this. You have a ready-to-run standard node image. Well, actually, it's not really standard here because it's for an HA Qlustar head node, but anyway, you have your chosen boot image. And then you can continue now with this image, and let's see what happens when a node boots. I mean, that's in most parts pretty standard for how an HPC cluster brings up nodes now. There's a little difference though. So what happens is you have the image on the head node generated like before. Then your computer storage node here asks the head node when it boots up per DHCP for its IP address, gets the PXE loader, which is responsible to bring up the operating system. It transfers the image to the compute node, then boots the Linux kernel and mounts this image as the root file system. So then you've got it here running as the operating system on your compute storage node. But now there is a second component that I briefly mentioned before, and that is this UniFS change root that is put actually as a layer underneath this node image. It's an optional component, I should say. You don't need to have this. But for standard compute nodes, or for instance for login nodes, the minimal stuff that we put in this base image is often not enough, because of course there are thousands of applications that any different kinds of users wants to run. So the question is, how do we get those in this image? And that's where this UniFS layer comes into the game. It's just put as a, oops, what did I do now? Go backward, okay. So it's just put as a layer underneath. And what does that mean? That means if a program or a file from the operating system is accessed on the compute node, what happens is that the system first looks, is this file or program part of the RAM disk image? Is it in this green part here? If yes, great, then run it from there. It's all local. It's incredibly fast. If it's not there, well, it's all there in the UniFS layer. That UniFS layer is just a matching change root sitting on an NFS server. And in this change root, you just have all the, I don't remember, 16, 20,000 packages of Ubuntu available. You just do apt-get install, pang, and it's all there, immediately on the node. And transparent here. It all is installed under /user, blah, 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 /user bin, /user lib, etc., because it's a layered file system. It's all merged together. So while you have this very fast part, which is sufficient for, let's say, 95% of the stuff the system needs, you have everything available for any kind of situation that your user maybe wants, or libraries or whatever they need. So that gives you the flexibility as well as the speed and the manageability. So let's get to the management architecture now. That's the Qluman part of it. It's our management platform. It's there to configure, operate, monitor the whole cluster. That's a central point of control, really, for the administrator. It's multi-user, multi-cluster. It involves a modern graphical user interface based on Qt. Very important point, especially if you have multi-user, is that it provides real-time updates of system changes. So if administrator A does some changes, be it written on the file system or just in the database, administrator B on his graphical user interface immediately gets this change in his GUI as well. So he sees, oh, administrator A just changed the image. Maybe he's done something wrong. Let's really call him up and let's revert that or whatever before it becomes active. So that's a very, very important thing. It's a complete in-house development written from scratch. The messaging architecture behind it, the network architecture, because it's of course a distributed system, involves reliable messaging. So there are no network traffic is getting lost. It's based on the ZeroMQ library. Who knows about this? And as I mentioned before, it's a totally scalable architecture. That's one of the main design principles in the system. I mean, this is just an overview. I'm not going to go into much detail here of the architecture of Qluman. Oops, again the wrong button. So most of the stuff, of course, is running on on the head node, or if you have multiple ones, on the head nodes, because it can be distributed as well in an HA fashion, for instance. You have a central admin service that is like a request broker. You have the GUI connecting to this admin service. You have the database part here. you have an execution commander, a monitoring service, and they all talk to each other. Here on the client node, you have the execution service to execute remote programs. You have the stuff for the monitoring state information service and so on. Let's have a look at a couple of features of Qlumen, that's behind the ideas behind it. So of course it has a host database, that's clear. That's a basic thing, IP, MAC addresses, and etc. Then it has this concept of host templates. So host template is actually the crudest, but in many cases sufficient way of assigning properties to nodes. So a host template actually consists of what we call a config set. Oops, I'm really having trouble with this button here. Of config sets, then generic and hardware properties. Actually sets, I forgot the set here. So it's a combination of sets. Set means different parts of properties. And that's, as I said, the simplest assignment of properties to hosts. Then, because this is often not specific enough, we have a hierarchical property assignment. So the idea behind this is to have a most to least specific assignment of properties. So rather than, or in addition to assigning a host template to a node, I mean that has to be done, but you can, in addition, if you need to, also assign config sets or generic property sets directly, or to be even more specific, directly properties or configuration classes to the nodes. So you have many different levels of being more and more specific, so you can actually manage to have any kind of control over what kind of property a node really should get. It also has physical management, that you can visualize your cluster with rooms, racks, host enclosures, and so on. That's in principle nice to see everything, but it's also convenient. For instance, if you say, okay, tomorrow I have a maintenance, I need to shut down all the nodes in rack 1, you quickly select rack 1, shut down, and that's it. So it's pretty convenient for that too. So again, this is a little bit blurred here. I hope you can see something. That's just a typical view of it. So that's a tree view here of all the hosts and the enclosures in here. Here the host information, templates, and so on. And here is the definition of these host templates that you can assign here to an individual node. Let's just go through quickly through a couple of examples here. Sorry, that was too fast again. So this is, for example, the way that you can assign a host template to some nodes. If you want to all of them at once as well, you just select here your nodes, and then you can select your host templates or other properties here. Then this is, for instance, the dialog to add new hosts. Fancy feature here is the MAC address detection in the network. So that's what you can do with that. Then we have here the dialogues to write files, showing when some stuff needs to be updated, otherwise it's grayed out and so on. It gives you actually a diff of all your generated configuration files here, so you can make sure that just what you need to do is really updated. So let's just give a final quick outlook of what's going to come. One very nice feature that we're going to have in the next release is that a completely new remote execution engine that is graphical, actually. It allows to execute remote commands on the compute nodes. That's nothing special yet, but the really nice thing here is that you actually can analyze the output, what is the output of these commands, and group them into failed state, errors, and so on, but then also in the content of the output here into different groups. So that's very powerful to actually see, especially if you have hundreds or thousands of nodes and you execute a command, did it really execute properly, or what happened there? And then just some highlights of the upcoming 8.1 release. As I said, we're going to support Debian and Wheezy. We're going to have the newest Offit release in there, 3.5. We're going to support Qlustar 2.4 with experimental CFS support. The feature release of OpenMPI is going to be included with GPU support. And in Q4, we're also going to provide as a new product, really, the Qlustar Cloud Adapter, which is going to allow you to extend your cluster completely into the cloud and fully integrate and control cloud virtual machines on Amazon or other nodes. And run a cloud-only cluster from your laptop if you want. Okay, that was it. Thank you for your attention. and enjoy the conference. And I hope you can come by and talk about it.